By far, my #1 requested video has been how to deploy an app to production, a full stack app to production. I've done a video in the past of how to build up a node and Docker development environment locally, but how to get that in production. In order to deploy something to production, I need something to deploy. So in this video, we're going to do a full stack app build where we use Node as a backend, Postgres for the database, Redis as a layer for managing a queue of jobs, create React app and React on the front end to build a front end, GraphQL to talk between the front end and the back end, and do all that locally. This will prepare us for a future video where I can then deploy that to production. Hi Kingsley, thanks for tuning in. So in this video, we're going to build as simple of an app as we can with those tools. And what we're going to build is a form collector. We'll call it Form Hub. And we're going to walk through this build step by step together, not quite from scratch. Instead, we're going to start with my ultimate Node and Docker setup that I've done in a previous build. This will give us a good starting point, at least for the back end, to be able to have a Node backend with TypeScript and Lint and Prisma and all that sort of stuff, building up from there. But I'm starting with nothing here, so this is live as we go. Let's get started. So like I said, our goal is to build a form collection app. We'll call it Form Hub. So this would be maybe if you had a website, you wanted to post a form somewhere and have some sort of app that collected that form data that you could then view and report on. So let's get going. We're going to start with the back end. So I'm going to go to this ultimate node stack that I have here. By the way, if you haven't watched this video before, I have another video on this on the channel that you can check out. I'll link to it in the description. And I also have this Medium blog post that walks through it step by step here as well. So I'm going to go grab the Git URL for this. And let's go create something. So let me go into my code directory. So I'm going to clone this into a repo. And I'm going to call this Form Hub and name it BE. This is a common thing I do whenever I have a full stack app that actually has multiple repositories. So in this one, we're going to have a Form Hub BE repository for the backend and a Form Hub FE repository for the Create React App front end. I haven't quite gotten into the mono repo thing yet. That's definitely something I want to do, maybe in a future video. But in this one, we're going to have two Git repositories. So let me clone this into Form Hub. Then I'm going to go into that repository. And because this is really its own new project, what I want to do is remove the Git history that we had from Ultimate Node Stack. So this is not an extension of Ultimate Node Stack. We just kind of use that as a starter. So I'm going to remove the Git directory within this project. And then I can do a git init, and now we have a fresh working GitHub or Git project for this backend. So let me open that up in my VS Code, and here we go. Now it's been a few months since we did the Ultimate Node Stack, and I imagine that there are several package updates. So because we're starting this fresh, I want to start with the latest and greatest in everything. So let's go ahead and update our packages. I'm going to run a yarn upgrade interactive here. This is a great way to inspect what is in your project, the packages, and select what you want to upgrade. So let's go in here. It's a little hard to read. Let me try that again. Okay, so I'm going to go ahead and hit A to just select everything by default. But let's go ahead and update SWC. That's what we're using to compile. Let's update our default tsconfig, our types for node, ESLint, that's fine. Prisma, that's good. tsnode, express, nanoid, PG, TypeScript. Okay, that's all good. So Yarn Upgrade Interactive is a great way to inspect those packages one by one and choose what you want to upgrade. Now the thing about Yarn Upgrade Interactive is it tries to do what is compatible with your package.json file. What do I mean by that? So if you go into your package.json file, you can see that in the versions of our packages, we're saying that let's do a version like 4.17. So if there's an upgrade here, 4.17.3, 4.17.4, then that would be a welcome and compatible upgrade based upon our matcher here. But if there's maybe an Express version 5, that's a major change, a breaking change, and that's not going to be picked up by Yarn Upgrade Interactive by default. But let's run Yarn Upgrade Interactive latest. So I just did kind of the safe version where it's compatible with all of our packages. But if I do latest, this will show me the absolute latest version for all of our packages. And now I can go in here and see if there are any upgrades that I'm kind of willing to break if necessary. I do want to use the latest version of Prisma for sure. Next, even Nano ID, I think I called that Nanoid before. Types, node, that's all good with me. So I'm going to go ahead and upgrade these as well. Engine node is incompatible. That's weird. First issue here, okay. Interesting. Okay, so something wants 18. Now I'm blanking and let's see. Okay, so the current LTS version of Node is 16. 18, I believe, will be LTS fairly soon. Let's check that out. Okay, so 16 is LTS until beginning of October 2022, and then 18 will become LTS. Let's just go ahead and use 18. So let me do, not NVM, Volta. I'm now using Volta to manage node versions. Let's do a Volta pin 18. And that should be node at 18. And that's going to install the latest version of Node 18, pin that to my repository. Let's go ahead now and run latest again and see if we can install the package that was blowing up. Okay, looks like we're getting further here. Excellent. Okay, now if you remember, this is all going to be running in Docker for the backend. And let's make sure after all these upgrades that we can still go ahead and boot our system. So I need to start the Docker app so that I have a Docker server running locally. So as soon as these little containers stop blinking, then this will be started. Now I did upgrade my packages here, so if you remember from the Ultimate Node Stack, I will need to rebuild my backend. So I'm going to do this in two steps. We're going to start up our backend in Docker itself, and then once Docker's up, then we can run the build. So let me do a DC up. Those are shortcuts I use in my other user profile. Docker compose up. Maybe I should do a video on shortcuts I use. So this is going to download a couple of different things. Now I see here it's downloading Node 17. That's not quite what I want because I just updated to Node 18. So let me go in my Docker file and what do I have? 18.7 here. So I'm going to update my Docker file to use the node 18.7 base image. Today's video is brought to you unofficially by Cold Brew. Okay, so we are installing the Node 18 build. That's chugging along here. I guess since this is building fresh, I won't need to rebuild after this comes up. So this is going to build fresh with the packages that we just upgraded. If all of that works and I can boot up the system, load up the page, then we will be good to go. Installing. Okay, here we go. Great, this looks good. Okay, all right. So we do have some issues here with Nano ID. That might be due to imports of modules, ESM modules. I'm not going to sit here and troubleshoot that in this video, so what we're going to do instead is I'm going to downgrade part of what we just upgraded and downgrade back to Nano ID 3. I think that will solve the issue. So I'm going to go into my change history here, and I didn't make an initial commit. I should have made an initial commit before I started doing anything. That would have been smarter. Feel free to do that on your own. But let's go ahead and downgrade to Nano ID 3 here and see what we can do. I'm going to open up a new tab here. Let's go and run yarn. Let's do a yarn upgrade interactive to make sure that I haven't pinned this to a too low version of 3. I want this to be the latest version of 3. Okay, that looks fine. Now let's do a yarn rebuild BE. I am curious. I do want to make sure. I'm going to open up my yarn log file. Okay, that is pinning it to Nano ID 334. Hopefully this fixes the issue. So I have this special command that is a part of the Ultimate Node Stack, yarn rebuild BE. This runs the much longer command required to rebuild our backend, reinstall the packages since we just made a package change. And we'll see if this boots up properly. Okay, so it's installed packages, installed Prisma. I'm fine with this removing. We got a different error. Okay, so this is cool. So it did try starting the server. In fact, it did start the server, but when Prisma tried to boot up, it doesn't find the posts table. That's actually great. That's great news. So what that means is Prisma started up, the server started up, but there's nothing in the database. So I have another command that will migrate the database to our latest state. Now, I'm not going to have a post table in this app, so I'm not going to do that quite yet. But I can see that things are booting, so I'm going to go ahead and commit all of these changes. So I'm going to say upgrade to Node 18 and upgrade dependencies, which I never spell out. Okay, commit. Yes, commit everything. Okay, now we have a base Node app with TypeScript, SWC, Next, Prisma, everything booted and going. Let us start with our database structure. Again, like I said, this is a form submission collection app. So what I want to do here is have a table called submissions. We'll have an ID, that sounds good. We're going to have, I'm going to keep this very, very, very simple. We're going to have a submitted at timestamp that is not nullable. We're going to have a JSON B column. If you make a JSON column, you probably want to make it JSON B in Postgres. And this is going to be our form data. So I'm going to just dump the form values into this data column. So just ID, submitted at, data, and then our traditional created at and updated at timestamps. This is now a submissions table, so I'm going to rename that in our down function as well. Now this looks good. So this is our migration. This is my personal choice. I do migrations in Next, and then my database access layer in Prisma might be unpopular, but that's how I do things. I really like the control of Next migrations, and Prisma is by far like the best database ORM in JavaScript, in my opinion. So it's a little bit of duplication when you're setting things up, but that is a very worthwhile trade-off to me. So I'm going to rename this to submission in my Prisma schema file. This is what defines the database schema so that when you generate the Prisma ORM client, it knows what your structure looks like, and it generates very nice TypeScript types for everything. So I'm going to basically get everything in here that we need. So data is going to be a JSON column. And let's make that not nullable as well. And then we have a submitted at date time. That looks good. Saving prettifies our file. Save this as well. Okay, that looks good for our database structure. Let's pull back up our console here and run our migration so we can add this submissions table. After that, we do need to rebuild Prisma so that it can generate the proper types. So let's run the scripts I have set up in here. One is docker db migrate. That's how we can run the migrations locally inside of Docker. So we'll do a yarn docker db migrate. There we go. So now we have a table in here. I'm going to do a yarn db console, and we can just verify that. So this opens up the Postgres console. I'm going to describe submissions, and there we can see we have our submissions table. Every column is required. This looks good. I like it. Okay, now we need to regenerate our Prisma client. Again, let's see. I actually have a script for that in some of my other projects, but I don't have that in here. So let's make a script. I like calling this build Prisma. And what we need to do there is run Prisma generate, and we also need to rebuild our backend. So we'll run a yarn rebuild backend. So let's run a yarn build Prisma. It was built successfully locally, so it liked our schema file. This is going to rebuild the backend instance now. Now let's pop open our source directory, and we can see here that our server from our ultimate node stack kind of template that we followed is utilizing this post table. And it goes ahead and seeds the database whenever it starts up. I'd kind of forgotten it does that. Let's change this over to submissions and just check this out. Okay, so let's follow this pattern, and if we have no submissions whenever the server starts up, let's go ahead and do a submitted at is now, and data is, let's say, name, Kevin Wade, Twitter, Kevin WW Wade. And we're just going to add one item. We're going to rename this submissions. Just want to do kind of a quick edit here because eventually we're going to use GraphQL. Okay, I'm going to save that, hit yes to here. That's booting up. Let me go ahead and restart. Let me restart the backend. Okay, it's saying it can't find the post table. Something is old here. So this didn't quite update for some reason. I'm going to Docker compose stop my backend, and Docker compose remove the backend. I think somehow the new build just didn't get started here. So Docker compose up -d because I already have the log running over here on the left. Still can't find the posts. Let's rebuild the backend. I'm not quite sure what happened there. I'm going to rebuild this one more time and see what happens here. Okay. Oh, you know what happened? Okay, here it is. In my submission model here, I'm saying the database table is named posts. That's not correct. Should be submissions. Okay, let's run that again, and that ought to fix it. Okay, so we can see it is able to query the database now. Let's open up localhost in the browser here, and we can see it is returning a JSON of that seeded record. So we just ran through a lot here. Primarily what we did was we took the ultimate node stack that I have, updated the dependencies, switched out the post table for a submissions table, edited our migration, and got everything running in Docker locally. Okay, so we have a post table, we have data coming into it, we have this JSON representation. Now what I want to do is I want to add a GraphQL schema for this because I want to use GraphQL in order to talk to the front end. Let me go ahead and save my progress here though in a commit. So what do? We added a script, we updated our database configuration for submissions table. That's the primary purpose of what we just did. So add submissions DB table. Okay, that's good. Now what we're going to do is for GraphQL, we're going to use Apollo. Apollo is my favorite way of doing GraphQL. It's used by a ton of big names and has lots of community support for doing some pretty cool things. So let's go to docs And I just look at the docs every time because Apollo changes pretty often. So let's see how they recommend these days to get started. If you're doing this on your own in a server, I would recommend checking out the latest docs to see how they recommend getting started. Now, I do use Express, so I know sometimes they have specific Express. Here we go, choose which package to use. Apollo Server Express. So depending on which web server you're using, if you're using Fastify or Express or something else, they have a different recommended Apollo server package to use. So definitely check out this choosing which package to use page. And so we need to install all of these things. I use Yarn, so I'm just going to copy the back half of this, and we will add that. Yarn, add the back half. Great. Now we can get started defining our Apollo server. Now, this is not going to be an in-depth tutorial, GraphQL. If that's something you want me to do, let me know in the comments. I love GraphQL. We manage, at my company here, we manage 4 different full stack apps, and we use GraphQL for all of them, and it is great. So highly recommended. Because I just added packages, again, rebuild that backend, something we have to do a lot here in the beginning, but that's okay. And we're going to get started. So I'm going to copy and paste this code in as a starting point, and then we'll fix it up for our purposes. So let's go to source, and let's go to, what does this look like? Start Apollo server, App Express. Okay, we're going to end up adding this in. We already have our Express server, so I'm going to copy this lower part into our index file here. And let's see what we need to change. Okay, so new Apollo server, I'm going to import that from Apollo Server Express. We need to import HTTP. Okay, we have type defs and resolvers. We'll go over that in a bit. CSRF protection, that's interesting. Actually, I haven't seen that option before. Cache bounded, and then a few different plugins here, which we will import from their proper places. We do have some start commands here. So kind of like their example, looks like we do need to wrap this in a function because we are using await. We don't have top level await yet, I don't think. So start Apollo server. I'm going to wrap this in an async function. And we'll run that here. Okay, now I can use await. We're applying middleware. We are already starting this server down here, so we need to get rid of one of these. Let's do we also are getting our port. Okay, so let's adjust this a bit. I'm going to rename this function just to, in general, start server. We are going to use our port variable, casting that to a number here, so that's good. And we're starting this HTTP server listen, port resolve, apply middleware, app. Okay, so I think I can get rid of this now. Now, one thing that's very important is in Docker, you do need to attach servers to 0.0.0.0 instead of localhost. So let's do that here. I imagine this is probably host. No. Let's look at the definitions. Port, then host name. Okay, so we have options. What are our options? Host. Okay. Not sure why that didn't come up earlier. Host. Let's define that before port, just because. Okay, saving that. That looks good. Type defs and resolvers. We don't have those yet. So let us start those. I'm going to create a new file called schema, and I'm going to put that in a GraphQL directory. So we have schema, and then we're going to have resolvers, okay? So schema is where we're going to define our GraphQL schema. So let's do const schema. We're going to use this GQL, what is that called? A template literal? A tag template? Something like that. And we're going to define our GraphQL schema here. So let's go back up to getting started here. Let's see if they have an example for us to glance at. Yes. So they call it type defs. I call it schema. This is where you would define your GraphQL types as well as a root level query type for what your query would look like. So let's define our query. And we're going to say on our top level query, we're going to have a submissions field. And this is going to return, right now it's going to return an array of submissions. If we have time in this video, I'm going to end up making this a paginated list of submissions, and I'll show you how I do that in GraphQL. Spoiler alert, I end up using the relay style pagination. So let's define a submission type. I'm not sure why I don't have color coding yet here. Let's define a submission type where we have an ID field, a submitted at timestamp. This is going to be a date time, which is not a built-in type. We'll get to that in a second. And also our form data, which is going to be a JSON type, which is also not a built-in type. So how can we get this date time and JSON type? Well, there are some really great simple packages for that. So I'm just going to search GraphQL datetime. And let's pull up the first thing here, taken from GraphQL ISO date. So this is a package that we can pull in to add a date time, date, and time, all three of them. So do they have those? It's a little harder to see here, but it's a date type, a time type, and a date time type, depending on what you're needing. So let's add GraphQL ISO date. Yarn add that. Now we also need a JSON type, so GraphQL JSON type. I know there is a package for this. Here we go, GraphQL type JSON. We're going to do that here as well. So we're going to add those in, and then you guessed it, going to rebuild. So yarn rebuild BE. That's going to rebuild our backend in Docker to make sure we have access to those types. While that's going, let's see how we install those. So when you define a custom type that is not like a object with fields. That's called a scalar. So we need to define that we have a JSON scalar type as well as a datetime scalar type. So let's come into our schema file here and say that we have a JSON scalar and we have a datetime scalar. Okay, that's good. Let's open up our resolvers beside this. And our resolvers are really just an object of resolvers. So let's do resolvers, and we'll add in our JSON resolver, which is a GraphQL JSON. And then our datetime resolver, which is something like graph datetime. Not showing up here. Let's see. Okay, GraphQL ISO date. How do we use this? Okay, those weren't showing up, but let's import those manually here. GraphQL ISO date has no types declaration, so let's add in the types declaration. I'm going to add that just to our dev dependencies. So date time. Now we could go ahead and add in these other scalars. We're not going to use those, but since we have them and they're common, I guess we could add them, or we could skip them. I'm going to skip them since we're not using them. But those are there if we needed them. So we're going to export default resolvers here and export default schema. Okay, saving all of those, that looks good. Okay, now type defs, I'm going to pull in my schema and resolvers. I'm going to pull in my resolvers, which is not coming up here. So resolvers, there. Okay, that's looking good. So we have schema, we have resolvers. Let's go ahead and build out our top-level query. So on our top-level query, we have submissions. Now you'll notice nothing is typed here yet. I will go ahead and add that in because I love TypeScript. I love having strong types in here. And this is just a willy-nilly object right now. So we are going to add in types for these resolvers in a bit. So let's make a function that returns these submissions, and we're going to use our database, which is not coming up. Okay, in this template that I started with, basically everything's in this index file. So we're going to pull some things out. So let's pull something out into, let's pull out a database file so we can access our Prisma client from pretty much anywhere. So I like creating a modules folder for common modules within your app. So I'm going to call this DB. And from our index file, instead of creating the Prisma client in there, I'm going to create that in our database file. Okay. This might be a good place to go ahead and put the seeding logic. In a real production app, I would create a separate seed script, but we'll go ahead and pull this in here for simplicity. I have this generate ID function. Putting that in the database file sounds like a good place. We'll move our nano ID import into here. Okay, so that's really thinning up our index file, moving our database featured stuff into this database file. And we're going to, by default, export that DB as the default export. Okay. Now we can import that in our main index file. Great. Okay. And now we can use this in resolvers as well. So let's see if I can just control space on here. There we go. Okay, so that's going to pull in my database module, database Prisma client for me. So let's go to submission, and we're just going to do find many. We just want to find everything, but let's go ahead and order them by submitted at descending. Alrighty, so that will return those. Submission has ID, submitted at, and data. Those are all going to be on this submission object from the database. So right now, I don't need to go in here and create submission resolvers for each field because those are going to be on the objects returned from Prisma. Okay, so I've made a lot of changes here. I do want to make sure this works. So we'll see if we can boot this up, and we'll use GraphQL Playground to run this and see what we can do. Okay, so let me save here. This is going to restart the backend, I think. Let's see, Docker compose restart backend. Okay, server ready. Let's go there. Site can't be reached. That's unfortunate. Let's go to the root. Okay, so we might, I took some of this server logic out. Okay, looks like it may just be what I'm logging here. So let me log the proper port, and let's make sure that's not just what we have. Okay, when I'm saving my files, I expect my Docker to restart my backend for me. I'm not sure why it's not. I should have, can I collapse this? Yes. I should have, in my VS Code extensions, this trigger task on save. Let's make sure. Extensions. This is installed. I'm not sure why, and you can even see it's restart web, it keeps running. I'm not sure why that's not actually restarting. Oh, because it's actually called restart backend. Okay, I need to fix that in my node Docker setup. Okay, backend. So if I save that, and now if I save a TypeScript file, okay, that's going to restart my backend for me. Glad we found that quickly. Okay, so that's restarting. It was on the wrong port, so let's open this up. Okay, and this is going to pull up GraphQL Playground. Oh, good. I was thinking I was going to have to do something different for that. Oh, they've changed this up a bit. Okay. So this is the GraphQL Playground. This is how you can test and run queries. So let's just open up a query here. Look at our submissions. We have all of our fields. Let's do ID, submitted at, and data. We can hit Command Enter to run that. And let me collapse this. Cannot return null for non-nullable field query.submissions. Okay. Let's see what might be wrong here. this should be returning many submissions. Oh, I didn't put a return statement in. That's my fault. Okay, I hit save, we've restarted, the server's ready. Let me hit run again. Yes. Okay, we have a basic GraphQL server. It is returning data from a database, which is an exciting point. Okay, I like that. Let's commit our changes because we have a working state here. So what did we do in this case? We added GraphQL server, we added resolver, schema. Okay, that's all basically to get GraphQL going. So add Apollo GraphQL. We're going to attach all of those changes. So we have this query we can run, we can get submissions, we can view this data, and that looks good. Okay, what else do we want to do in this app? I want to be able to generate a whole bunch of submissions using Faker or something like that, as well as queue up the generation of those as background jobs. And then finally view these in a table. So let's take, we could do this in a couple of different orders. Let's take it a step at a time though. I kind of want to just get to doing the front end so we can actually see this data come through and then start building up the creation of the jobs of creating fake submissions and things like that. So let's build a front end. Okay, so we have our backend in a good state. We have a GraphQL server. We can use this query now on our front end. And this is all in, like I said at the beginning, this form hub -be repo, BE for backend. I'm going to create the front end in a separate repo. You could, like I said, use a mono repo or something like this to put all these projects together. I do want to do that, just don't have a lot of experience with that yet, so I'll save that for a future video maybe. Maybe we can figure that out together. But let's create a separate repo. We're going to use create React app to initialize a React app, and then use our GraphQL to query these submissions. And let's get going. Okay, so let's go over to, let me move my terminal here to a different desktop. Okay, so let me go to my code folder that I use. We'll run npx, that helps us execute something. Create React app. I do want to do TypeScript, which I usually forget how to do that. I think it's template TypeScript. Template TypeScript, yes. Kind of wish you could just do -- TypeScript. Okay, so we'll do create React app, form hub FE for front end, and template TypeScript, because we love TypeScript. Yes, that is fine. It's going to install everything we need here. We'll take another sip of cold brew. This is a sweet cream cold brew, something like that. Thanks for the people who are tuning in live to this. That's always fun to see. I do have my chat open. If you're watching this live, I do have my chat open here to the side. I can see any chats that you might have coming in. Okay, so we have this now. Let's open that in another VS Code window. Let's do some window arranging here. Okay, FE. Now, let me tell you about a choice I make. I do not run front-end projects in Docker locally. The reason for that is hot reloading. the file, kind of like we experienced in the ultimate node stack, our strategy for restarting the server on the back end is that VS Code, whenever you save a file, restarts the server for you. A lot of times if you're developing locally without Docker, you can just kind of watch for file system changes, maybe with something like nodemon. The package or technology or whatever it is that watches file system changes is very inefficient in Docker, not nearly as efficient as your local machine. So because of hot reloading and things like that, I just run the front ends outside of Docker. I leave everything else in Docker, so I leave Postgres in Docker, the back end. We'll get to adding Redis here in a bit too, but for the front end, I leave that separately. So we're not going to do anything in Docker for the front end, except in the future video where I deploy this to production. Then we'll get to how we do that. Okay, so we have a Create React App project here. Let's open up our package.json, which is always a nice, friendly way to see how you start up a project. So I'm just going to do yarn start here. That should start things up. We're going to open it up in a browser, and we have that. Excellent. Did this start a Git repo for us? It did, and it's already done our first commit. Okay, excellent. So our very first step is to close some tabs. Let's pop open, they've changed this too. Let's pop open the Apollo client React docs and see how we get started. Okay, so we're going to install Apollo client and GraphQL into our front end. Hey Farik, thanks for tuning in. Farik, sorry for mispronouncing. Okay, add, let's see. Looks like Create React App uses npm by default because it found this package.json file. I just love Yarn. Use whatever you want. That's cool. We'll remove this package lock file in favor of our Yarn lock file when that generates here. Okay, so all of those things are installed. Like I said, let me remove that package.json because we're going to use Yarn. We've installed the Apollo packages. Now let's initialize our Apollo client. So I'm going to copy this and go into our app file. And we're just going to do everything in app for now. Client. What do we have? And then we have provider. Okay, so let's define our provider in this app file. Okay, so we have our Apollo client. Let's import that from the proper place. Let's import in memory cache. Our URL will be this localhost URL. And so we will make that our instance there. Okay. Now we have to define this client, and then we create a provider so that anywhere in our stack we have, that makes a context behind the scenes, so we can access the GraphQL. Okay, so I'm going to basically delete all of this. Then we'll have our, let's see, then we're going to have some sort of table here. Insert table. Close Apollo provider. Okay, so let's import our Apollo provider. We're passing it our client. I'm gonna, okay, so there's this, so see, I'm not using these imports now. I freaking love this command if you don't know about it in VS Code. Open up your command palette, organize imports. Does a couple things. It removes your unused imports and alphabetizes the ones you are using. I love that. I run it all the time. Okay, so we have that. If I pop open our interface, we have table. Not very helpful, but we'll change that. So we have this here. I don't know if it's working though. So let's create a component that queries, and we're gonna end up displaying a table of submissions. So let me create a let's create a screens directory, and we'll create a dashboard screen. That sounds good. Call this TSX. Do I have that in here? I don't have that in here. In my other user profile, I have a snippet where it creates a React component for me quickly. So we'll do this by hand. Dashboard. This is going to be React function component. Return. We'll do what I did before. Dashboard this time. Export default. Dashboard. Great. I'm going to pull this to the side. And instead of just hard coding table here, we'll pull in our dashboard component. Okay, we'll save that. Now we have dashboard. Okay, we have multiple files working now. Let's try out a query. So how do you use a GraphQL query in React? So there is this really great hook called useQuery. Then we can pass that a query, again using our GQL template thing here. And we can try our query. So let's run a query. I'm going to call this submissions query. And I want to get all the submissions, their ID, submitted at field, and data. Okay. We're going to return this into some variables, data and loading. So loading is a Boolean. So for loading, I'm just going to return loading ... Otherwise, we should have some data. There's also error. But in any good starter project, we're just going to ignore errors. No, you should totally handle your errors. But let's just stringify, just so we can get some output here, what this data is. So I'm going to save all of this. Boom. OK, so this worked. Let's open up our inspector here. We can see what's going on. If I refresh, I have never seen it laid out like this before. Is that because it's too big? Okay, maybe I have. This just looked weird to me up here. Oh yeah, isn't it? I don't. There we go. Okay. So GraphQL, our useQuery hook here, submits this query using our Apollo client to the URL, which is our backend running in Docker. Sends this query over, gets the data. It loaded super fast, so we didn't even see this. And then it's outputting the stringified version, and we can see all of that here. If we open up our network inspector, we can see the GraphQL query happening here. It sent to our backend the stringified version of that query, and the response is our root level data, the submissions field in our query, and then an array of submissions with ID, submitted at, and data. So we now have a GraphQL query running on the front end that's going to the back end. Oh, thank you for, I'm sorry, I don't know how to pronounce your name. Farak, found my channel yesterday and appreciate you creating content building here in step 0. It's helpful and wonderful than classical tutorial. Awesome. Thank you personally. Thank you, thank you, thank you. That makes me feel really good. Okay, let's see. So we have this data. This is not very helpful. I'd like to look at this in some sort of table format. So what we're going to do here is use Material UI. So Material UI is Google's material design interface, and there is a really great library that has pulled this together into a bunch of React components. And one of those components is a data grid. And so this data grid allows us to look at a table of items. So let's install this and use this data grid. Now let's see how we install Material UI here. Overview. Thank you. We have advanced components, core. Okay, apparently there's this MUIX and MUI core. Oh, they have different UI systems now. Interesting. I didn't. Every time you look at these things, they change. Okay, installation. We're going to use the Yarn version. This looks good. Okay, so let's add that. We're in our Frontend project. Okay, so we're going to add that, and then the database table, that's apparently an MUIX. The database table is its own package, so we're also going to add that. Yarn add that. All right. Let's go back though. I bet there's some sort of provider we have to end up adding in. Okay, Roboto font. Okay. Let's add that in so that everything is happy. Font icons. I don't think we're going to use icon. Well, okay, let's add that. SVG, CDN, blah, blah, blah. Okay, usage. We may not have to make a provider. Okay, so let's see if this works without it. So MUIX, data grid, overview, import data grid. Let's look at the source for this example. Okay, so a couple different things going on here, but it all comes down really to this data grid component. So I'm going to go into my dashboard, and we're going to return a data grid component. And we need to define rows, columns, things like that. We're not going to do checkboxes right now, so we're just going to remove that. Let's remove the page options. We might get to paging later, depending on how long this goes. How long are we in? Okay, we're an hour in right now. Let's see. So we need rows and columns. Okay. Interesting thing about our form collection app is we don't know what all of the columns are, because this is going to be quite dynamic. Again, we're just like dumping our form data into that JSONB Postgres column. So we're going to have some dynamic columns here. We have field, header name, and width. And lots of different options here. So let's just start by defining some columns. We know we have an ID. We know we have submitted app, and then we have a bunch of different things. So let us come in here. We're going to import this. Let's just do ID for now, and submitted at, we'll just say submitted. Now we have columns. Now let's import our data grid. Now we need to generate our rows. And our rows are going to simply be our data dot submissions. Okay, let's see if that magically worked. Okay, I do see, it says, let's see, 10101. Let's pop open a little debugger here. I do want to see data.submissions. Okay, so data.submissions has an ID, has submitted at. Okay, that's good. Columns, ID, submitted at, that's good. I'm not sure why this isn't displaying. It's either a CSS issue or we're just really not displaying anything. So let's see what we have going on. It looks like we have no data. Oh, we are passing in data. Let's see what this does. Nope. Okay. Let me remove my debugger. I do believe we have rows here. I am going to console.log those out. Rows, okay, we have that. Let's look at this example again to see what kind of rows it's expecting. This looks pretty simple. We've got ID and we've got submitted at. I wonder if width is actually required. I cut that out for simplicity, but let's put these in and see what happens. Okay, use resize connected parent DOM element data grid has an empty height. Okay, it is a CSS issue. So we need to wrap this in something that has that expands. Let's add in a component here that expands to the full height of the page. MUI, Material UI uses emotion styles by default. Let's just go ahead and drop in on that. Let's see, emotion styled. Emotion styled. Okay, so we're going to create a container. Which is just a div. And this is going to be a flexbox that is 100 vertical width and 100 vertical height. This is going to be our overall container for the dashboard. Let's see if that makes Material happy here. Okay, excellent. I don't think it was the width. Let me go ahead and take these widths out. I really want to keep this as simple as possible. Okay, never mind. Let's put them back in because I do want to be able to see things here. Let's just do 200 for now. Okay, so it was a CSS or display issue, which makes sense because data grid uses kind of a virtual, I know that there's a term for this. It uses a virtual area whenever you're scrolling just a ton of data. It doesn't put all of the data in the DOM. And so it needs a visual area to put that in. So we have an ID and submitted timestamp for our row here. Now let's add in dynamically the columns. Okay, so Skia asked, hello, are you going to use Prisma in order to interact with Postgres? Yes, absolutely. In fact, if you back up a little bit, we are loading this data via GraphQL via Prisma. Just very simple Prisma stuff right now. Okay, so let's add in our dynamic columns in here that we're getting from our data. So what I want to do is close our extraneous files. What I want to do is add in additional columns here. So I want to take our submissions, which I'm going to pull out into a variable. I'm going to take our submissions and find all of the unique columns that we want to add. So let's do, let me add in Lodash because I pretty much use Lodash and everything. Yarn add Lodash. And I know Lodash doesn't come with types. So we'll do yarn add in dev dependencies types for Lodash. Okay, so I want to grab the a unique list of all of these submissions columns. So let's look at our submissions and flat map their keys of the data field. Okay, so on each submission there's a data field that is an object. We want to grab its keys, which is an array, flat map those. So we have a big O long array of all of the column names. We're going to unique that because they'll be very much repeated. And then we're going to map that, which all of those will be fields. We're going to map that and create field and then header name. And we want some sort of like more human-friendly name for this. Camel case, kebab case, snake case, start case, uppercase. Isn't there like a human case? Start case. That's good. Okay. So our header name will be start case of the field name, which is a camel case field. This is going to return an array. We're going to spread that. Field is a string. Why doesn't it like this? Field and value are incompatible. Okay, submission is of any type here. I'm going to call this any, and we'll update this in a second here. Okay, I'm just trying to get this to work so we can move on to the next step. Field and value uncombined. Unknown is not assignable to string. Okay. As object. Okay, this is not liking me right now. Okay, field and value are incompatible. Flat map any. Okay, this is going to end up being an array of strings. It's really not liking this. Okay, what I want is real types. Let's back up a second. One great thing about GraphQL is that it is a typed system. You get a typed set of data back. But right now our query is just kind of this string, and it's loading it into this data object which it doesn't know what type that is. So let's use a generator to generate for real types of our submissions. So GraphQL types generator. Looking at the Apollo article here, which is always good. This Apollo CLI. I think this may be, okay. Are you here for code gen? Why, yes, we are. Let's go to GraphQL code generator. Great. Okay, we're trying to generate types from the front end via React Apollo. Let's look at installation. Okay, development workflow, React Apollo server, React query. We're not using React query, post query. That is what we want. Development workflow, yarn, generate GraphQL codegen. Okay, so we're going to use GraphQL codegen to generate types. Let's add this in. Yarn GraphQL code generator init. Okay, so we're going to install this project. What this does is GraphQL code generator will be able to query our backend, introspect our schema that we've defined on our backend, and generate the proper TypeScript types for the returns of our query. That's a lot of words. Let me show you how all of that will work. So it looks like we need to initialize GraphQL code generator. Application built with React. Yes. What is your schema? Path. Okay. Let's open up app. We have that here. This is a nice handy initializer. What are your operations? Where are your operations and fragments? None of that. I'm just going to hit enter. Okay, TypeScript, pick plugins. TypeScript React Apollo sounds good. Source generated GraphQL, that sounds good. Do you want to generate an introspection file? I don't know. I'm just going to hit enter. How to name the config file? Codegen, sure. What script in package.json should run the codegen? I like calling mine build types. Okay, so what this should do, we've generated a codegen file. That's good. This is looking for documents. We're not going to have that. So I'm going to delete that line. And it added a script here to build types. So let's run yarn build types. What this should do. Unable to find template plugin, matching TypeScript operations. Okay. Did I miss something? Perhaps. TypeScript operations. It's a perfect play if you prefer only manipulating generated TypeScript types. Okay, perhaps this needs to be installed. What this should do is go through our React components, find any queries we're using, and generate types for those queries. So let's run yarn build types again, see if this, okay, we got some greens. Let's see what happens. So we have a generated file, and we do have a submission. Okay. What I really expected to see here is a submission query. So let's look at React, Apollo, best developer for Apollo. Okay, that's good. I have to say, these GraphQL code generator docs, not the clearest. I'm actually going to refer real fast over to another project of mine where I have this set up. Give me just a moment. I have it right here. Okay. Okay, documents. I feel like this documents is my issue. Because I'm wanting it to take it from our React components. GraphQL, code generator, React queries. That's not going to get me what I want. Apollo. TypeScript React Apollo. TypeScript React Apollo. In order to use GraphQL CodeGen plugin, make sure you have GraphQL operations set as documents in your CodeGen. TypeScript React Apollo. What did that end up creating in our CodeGen file? TypeScript React Apollo. Okay, we're actually already using that. Config with hooks. Config with hooks true. That may be what we need. Path to file, plugins, introspection. I don't think we need that. Let's check this out one more time before I take a look at our reference project here. Still not quite what I want. I'm expecting it to automatically find our queries from useQuery. Let me take a look at another project real fast of mine, because I have this working. Oops. Looking on my other device over here. I have this working in another project, so let's take a look at this. Bear with me for just a bit. looks like, let's see, I'm using the previous Apollo code gen in other apps. Okay, am I just going through this too quickly? GraphQL code generator, docs. Documents field. What I really want, yes, this is what I want. Let's see if that works. Okay, here we go. We now have types. Okay, that's interesting. It automatically appends query. Okay, we're getting there. So what I was missing here is the definition for how CodeGen should go about finding our queries. And what it needs to do is it needs to know that we want it to look in our TypeScript and TSX files. So that is finding this. Let me show you what this does. So we have a query called submissions query. I'm going to rename this to submissions because of what I saw in the generated output. What this will do is I renamed this to submissions, ran build types again. That generates this TypeScript file, and it generates a type called submissions query. So we can now use this, pass this type into useQuery, and this data object will now be typed. And there could be an error. Okay, so if it's loading, show loading. If there's an error, return error. Message. Submissions does not exist on type submissions query or undefined. Okay, data is submissions query or undefined. That's kind of annoying. Okay, so it's saying that data could be, let's see, it's saying that data could be undefined. I'm going to put an exclamation point there for now to say that it's not, because we're already checking for loading an error. I know there's a better way to do that. I may think of that in a minute. Okay, so now that we have the types, what we were trying to do here is we wanted to get fully typed version of this data output, because in our submissions now, in this function we've created to find all the unique column names, we now have strong types for this. I don't have to go in here and try to finagle the types because they're going to be exactly what we need. S.data is going to be an object. Keys is going to return a stringed version of those keys, so it knows field's going to be a string, and all of our types are checking out here now. I'm not getting those red squigglies anymore. Let's see where we stand now. Excellent, we're getting closer. So we have name and Twitter. So those are our two dynamic fields that are in our submissions. Let's go ahead and add widths onto these columns too for now. Now you notice we're not showing any data here. So why is that? Well, that's because these two fields are not directly on the submission. It's inside of the data field on the submission. So we need to define a custom getter. As you can see here, my tabs are absolutely out of control. But we're using lots of things here, so let's do this for now. we have a value getter. That is what we want. Say, okay, so we're going to define a custom value getter, which is a function, and we're going to return params.row.data field. So we're going to look in the data object and fetch the field that we're looking for. Cross your fingers. Yes. Okay. So we're pulling this data from the backend via GraphQL, piping it into this table, figuring out the dynamic columns that we want to display here, and that all seems to be working. Yes. Okay, we have done a lot on the front end. Let's commit our progress. So we added code generation. It made this GraphQL schema file. I think that was from our introspection moment. Let's make sure it's not building that again. Okay, it's not. We don't need that file. We removed package.json lock in favor of yarn. We've added in the stuff we need for material UI. We added Apollo. We've done a lot here. Okay, so let's say that we've added Apollo client and our initial dashboard screen. Excellent. So we have this now. Okay, so we have a base setup with a backend, Postgres, Apollo setup on the back end for GraphQL, Apollo setup on the front end for fetching, data grid for looking at the data. The next thing I want to demonstrate here is, again, we're trying to build out a full stack app that is kind of a demo app that we can then use to deploy to production in a future video. Our components so far are Postgres, Node on the back end, Create React app on the front end. I'd like to add in some Redis because that's a really interesting use case. I end up using Redis in all of our apps for some caching, but honestly primarily for queuing and job scheduling. So what I want to do here is I want to create some functionality where we have a button we can hit on the front end where we can really quickly generate 20 submissions. And how I'd like to have that work in order to demonstrate the use of Redis is when we hit that button, I want it to queue up 20 jobs where it creates submissions. And that will help us use a queue. It will also help us use a button here on the front end, which is where we can get into a GraphQL mutation, things like that. So we have a end-to-end base demo here of showing this data displaying. So let's get to building out a button to generate form submissions. We'll start with the backend. So let's say we want to have this button. Let's say it generates 20 form submissions. We want to generate those dynamically. Faker.js is a great way to generate data. Now I know Faker went through some sort of controversy. There was I don't know. But I think this has been resolved. Here we go. Yeah. Okay, so we're going to use Faker to generate fake data. And you know what? Let's see. I'm going to pull this out. We're going to open up a new window, new desktop, pull this away. Okay, so we're going to use Faker to generate fake submissions. And for our queuing mechanism, we're going to use a queue I like called bullMQ. The thing I like about bullMQ is that it is very TypeScript friendly. I also just really like how this works. So we're going to add bullMQ on the back end as well as Faker. Okay, so I've switched back to backend here. I'm form hub BE, yarn add bullMQ. I also want to add Faker. Now it's recommending you add this to your dev dependencies. We're actually going to use this live, so I'm going to add this to our main dependencies. Okay, so we're adding bullMQ and adding Faker. So you can see here with the basic usage of Faker, we can generate a random name, we can generate an email address. So let's say we want to build this form submissions app that generates or allows us to view maybe some contact form submissions from a website. So those might have name, email, phone, some comments. We got company, that'd be good. Let's see, lorem ipsum for comments. Okay, so our dependencies have installed. While we're building this, I'm going to run the rebuild BE so we can get those dependencies installed in Docker. So I'm going to create I want to create a mutation that we can run. A mutation in GraphQL is the ability for the front end to trigger an action on the back end. So I'm going to generate type mutation, and we're going to generate submissions mutation. And this it needs to return something. Now it's really going to be queuing of generate submissions. Queue submission generation. And honestly, I think I'm just going to return true. There's nothing really to return here because we're queuing. We don't have anything specific to return yet. So that is the mutation definition in the schema. So query, let's define that in here. Mutation, queue submission generation. Okay, so I want to enqueue submission generation, but we need to set up our queue. So we've added bullMQ. Let's go ahead and set up our queue. Now there are a couple of different parts to this. First, you have the queue, which is the communication with Redis. We'll need to add Redis. As well as the worker. So when the backend boots up, you would want to boot up a worker so that it can listen for the jobs in the queue and perform those jobs. So let's create our queue. So I'm going to create a new module called queue. Gonna paste in our basic queue here. So new queue, we'll just call this our default queue. These are jobs, and the jobs have job names and data. And then worker works on those jobs. I'm going to put all this in the same file. Okay, so we have a new queue. We're not going to have that. We have a worker, which listens for the queue. Let's create a variable called queue name. It's listening for particular types of jobs and then executing those jobs. Okay. So we want to generate submissions as a job name, and I'm just going to log should generate submissions. Okay, so we're going to start this up. Let's see if anything happens in our console. What I imagine should happen, and it doesn't look like it is that it should blow up at us because it can't connect to Redis. Now, I'm realizing here that one of the reasons is there is no, this file isn't being executed because it's not being used anywhere. So let me export our queue here because we're going to want to use this to enqueue something. So we're going to like add jobs to our queue. Okay. So we're going to add a generate submissions job. In fact, you know what I'm going to do is I'm going to create an enqueue function that has a job name which we're going to type here. And it may include data. For now, for our use case, it won't. But let's add in an API for ourselves here. Let me pull these side by side so we can see it. Okay, so I'm creating an enqueue function that will add a job name onto the queue along with some data. So over here in my mutation, I can say enqueue this job name, and we're not going to include any data. So in fact, that's going to be, could be undefined. We're going to end up doing this 20 times because I want 20 jobs, but let's just do this for now. Okay, cannot find module bool mq. For some reason, once again, our rebuild has not been the happiest with me today. Let's try this again. Let's see. Skia, did you try TanStack Table before? It's an awesome alternative to Material Data Grid. I have not tried that. But I'm always looking out for new stuff, so I'm going to check that out later. Thanks for mentioning that. TanStack Table. Okay, so we got our dependency installed for BoolMQ, and we can see we're having an error connecting to Redis. That's exactly what I expected because we don't have Redis. So let's add Redis to Docker and get that set up in here. So I'll open up our Docker Compose file, and we're going to add Redis. Now, Redis has, of course, its latest version, but looking forward to our production deployment, this is a little peek, I'm going to end up deploying this in a future video to production via Render. Render is a great hosting platform. It's built on top of Google Cloud, but it's kind of like if Heroku didn't stop innovating. Heroku's kind of been stuck for a decade or so. Render is a great way to deploy services to production. They make it very easy to deploy multiple services grouped together. They've got Postgres, they've got Redis. You can deploy backend services, you can have background workers going, you can have some services that are private and only accessible within your private backend network. You can deploy public services. It's a great platform. I couldn't say enough good things about it. So what I want to do is I want to make sure that we're using the same version of Redis that Render would be using. And Render says that they're, as of this recording, they're on 6.2.5. So whenever we add Redis to our local Docker, I want to add that same version so we can have as much parity with production as possible. So I'm going to add a service to our Docker Compose file called Redis. And it's going to use the image Redis. That'll be the officially supported Redis image of this very specific version. We'll say Alpine to make it as thin as possible. That may be all I need to do. I'm going to hit save here. What we also want to do is create some environment variables that allow us to pass into the backend the host name of the Redis server. So I'm going to add in an environment variable that is Redis host. And in Docker Compose, you can use your service names as host names. So our host name will just simply be Redis. So when we're creating our Redis config for BullMQ, we can pass in this environment variable for our host name. Let me save this. I need to Control-C out of my Docker Compose because I've changed my file. We'll run up again, and now it's going to begin pulling that Redis image. So it did that pretty quickly. Let's scroll back up here to see if that looked nice. Let's see. Okay, server initialized Redis, ready to accept connections. That looks good. Our backend still can't connect to it. That's because we're not utilizing this environment variable anywhere. So let's take a look at the docs for BullMQ. And I imagine there is connections. Connection. Okay, so when we are attaching to, when we're creating the queue in worker, looks like we can pass in a connection with that host option. So let's go to our queue file. I think we're good with Docker Compose now. I'll leave that up for this. Okay, let's go to our host file and let's define our connection config. What did that look like? Connection host. Okay, connection is going to be host, and we're going to pull in that environment variable Redis host. And one thing I like to do is anytime we're using environment variables like this is go ahead and just do a gut check. And if it doesn't exist, give us out a warning. So maybe we're booting this up in production or we're booting up on someone else's local machine. This will give us a nice, we'll log ourselves a warning in case it's not defined, is not defined. Otherwise, we're going to use this connection. Okay, so when we create a new queue, we're going to pass in our connection config, which it doesn't like for some reason. It gets passed in an object. Okay, and then same thing for worker. It's passed in at the end. Oops. Okay, so let's save that. That restarts. I don't see any connection errors, So it looks like now our worker and queue are likely connecting to our Redis instance. Okay, that's good. So we have a queue set up, we have a worker. Let's create a module for, let's create like a generate module. What I do when I define modules, and you haven't seen it thus far, but if I'm grouping a set of functionality together, what I'll often do is create something called mod, and then whatever the module is. So I'm going to have mod generate, and that's going to be my default export from this module. And then I'm able to use that throughout the app. I'll kind of show you what I mean. So mod generate, and I'm going to say fake, let's see, fake submission. Let's just call it submission. Okay, and we're going to use the database to create a submission where we have an ID. Okay, let's go back to our database file. We have this genID function. Just going to export that as a part of this. So genID submitted at is just now. Why didn't it like that? Oh, we're in Prisma here. Data. Okay. And then our submission data. What do we want our submission data to be? Get some of this out of the way. This is where we want to do our fake submission data. So let's do a name. Let's do faker.name find name. Find is kind of weird. Email faker.internet email. Let's do a company. Company name, that looks good. And let's do some comments. Looks like there was some good old lorem here. Let's do a paragraph. Or just, how about some words? Of some random length. Faker lorem words. Faker lorem words of some length. So let's do random from Lodash. I don't think we're using Lodash on the backend yet. So I'm going to add that to the backend. I'm also going to add to dev dependencies the types for Lodash. Lodash has a nice little random function in it where we can say random see. Okay, so we can say a random of, say, 30 words, and I'm going to pass false because I don't want it to be floating point. So up to 30 words for a comment, and that's going to be create. Now this is an async function, so we're going to await that creation, and we'll actually just return this record. But it will create it in the database. So submission. Great. Okay, I have this module here. Let me show you how I'm going to use it. Ooh, 1 second. Okay, I have this module here. Let me show you how I'm going to use it. In our resolvers, we created this mutation to queue submission generation. and we are saying in queue generate submission. So we are enqueuing a job called generate submissions. Oh, this has no effect. When this job runs, we want to generate submissions. So I have just this log running right now. Let's go ahead and try to trigger this from our mutation to see if we get this notice in our log. So let me pull up, trying to get our windows under control here. Okay, let me move my playground into a different window here. Okay, so instead of querying, we want to generate a mutation or run a mutation, queued submission generation. It says cannot return null. That's okay. Should generate submissions. Okay, so this did, I'm sorry, clapped into the microphone. This should generate, or should queue up a job. There are a lot of pieces here. Let me back up a bit. We created a mutation type in GraphQL, queue submission generation. We've executed this mutation from our GraphQL playground. That then goes into our resolvers, enqueues a job called generate submissions. So immediately, nothing happens but the enqueuing of this job into Redis. When that job runs via our worker, if the job name is in fact generate submissions, then we're getting this console log statement, and our test made it all the way through that process. Now we want to actually generate that submission. So I'm going to call my mod generate module and call submission. Now since we're here, let's just go ahead and log that submission just so we can see it here. Okay, so I saved that. Everything's restarting. That looks good. Okay, so I'm going to run this again. This is failing. I'll show you why in a second. But it did come in here and it generated this submission and it saved it to our database. So we have an ID, we have submitted at, we have our data, we have our comments, all of our fake data in here, which is great. And in fact, if I go over to our front end and refresh, we now have this data appearing in here in our data grid. Yes, you're exactly right, Vlad. This is cool. Okay, it's working. Okay, so a couple of things to clean up here. So we have this generating. That's good. Oh my gosh, you can press. I did not know you could press together. I just learned that. Okay. We're enqueuing the job, we're generating the submission, we're saving the submission. This is failing. That's what we want to fix up. Okay, so cannot return null. Well, that's because in our schema we're saying queue submission generation is a Boolean, but we're not returning anything in our resolver. So we're going to enqueue that and just return true. So when I hit submission generation, that's going to return true. If I go in here, I should see another submission. Now, I really want to be able to queue up a lot of those at one time. So I'm going to allow passing in of an argument here. I'm going to call it count. We're going to say that this is an int. Okay? So within my mutation, all mutations to be have the same function signature as fields. Mutations don't have a first argument. I know that's kind of weird, but that's how it works. Count, our argument, comes in as the second argument here. I know that it's an int, it's a number. There's another way that we can generate types here on the back end. We may get to that. We may not. But I want to be able to pass an account here and say, hey, let's generate 10 at a time. Let's generate 20 at a time. So I'm going to use the times function from Lodash to either execute count number of times or just once. And then for each of those, run this in queue. Now we've got a couple different issues here because we're kind of an async world. So what I really want to do is await the enqueuing of all of these. It doesn't await the execution of them, but it awaits just the fact that they were queued. So instead of doing a for each, I'm actually going to do a map. Then I'm going to map an async function over that, which will return an array of promises. And I can say await all of those promises with an await promise.all. So if I don't pass an account, it's just going to run this one time. Otherwise, if I do pass an account, then it will run it X number of times. So let's refresh here. We have 3 submissions. Let's say that I wanted to generate 5. So I'm just going to replace this, do 5, execute that. If I go back over here and refresh, I do have more than one submission. Now, this table is only displaying 5 records at a time. Who only looks at 5 records? Let's change that in our front end. So I've switched back over to front end. Let's go to our dashboard screen. I do have this page size thing in here. Let me comment that out and see what the default is. Okay, so this is showing all of them now. So I had 3 to begin with, and then by passing in the count of 5, then I was able to generate these additional 5 submissions. Cool. Okay, that all seems to be working. Let me go ahead and commit this on the back end, then we'll build a button on the front end. Okay, so on the back end, we added Redis, which was actually pretty simple with our little 1 or 2 liner here in Docker Compose. We added BoolMQ. We added this mutation and the generation. So we're going to say add Redis, BoolMQ, and submission generation. Nice, short but descriptive commit message. Okay, now let's create a button at the top here of our dashboard that runs that generation and with a bunch of submissions. Okay, so on our dashboard, all we have right now is our data grid. So let's create maybe a toolbar with a button. So let's say we want something called toolbar. This is going to be a styled div. And I want everything to be on the right-hand side. So I'm going to make this a flex box. By default, we want to see if I get this right live. Justify content at the flex end. Then let's make a button, which is a styled button. This may not have much styling. Let's just do a background of black and the color of white. Okay. So let's have our toolbar and a button. Let's say generate submissions. Oh, My iPad quit out on me over here. Okay. Let's see what this looks like in our interface. Okay, so by default, Flexbox is in rows. I want my screen to be in columns here. So our container, I want its flex direction to be columnar. Okay, we have our toolbar now up here, generate submissions button. Should we make that gray a bit? Let's add some padding in our toolbar. And let's add some padding in our button. Okay, it's a very large button. Let's just, for kicks, let's do a border radius of 8 pixels. Let's remove that box shadow. And let's make this padding a little less vertically. Okay, it's actually, it's not box shadow, that's the border. Trying to get rid of this thing there. Okay. Great, okay, so we have a generate submissions button in our toolbar. It's quite large and in charge, but that's fine. So now I want to be able to click this and have that run the mutation. So, kind of like we have a use query hook, there's also a use mutation hook. So I'm going to create that. So we have query. Let's go down here and say use mutation returned an array. Use mutation. We'll define that in our GQL string. This is going to be mutation generate submission. This name, by the way, for both mutation and query, that's whatever you want to call it. That's just whatever you want to name that query. It doesn't have to match anything on the back end. It's what you put inside of these that matter. So I'm going to run the mutation generate submissions. That's not what it's called. Called Q submission generation. And we want to run this with a count of, say, 10. Actually, I'll show you how to do this. So we're going to have a variable here. So count is going to be an int. We'll pass that in here. And then we'll pass in a variables of count 10. Mutation returns an array. Really, it's a tuple, but JavaScript doesn't have tuples. An array where we can generate submission, where the first item is a function that executes this, and then the second item is similar to queries where you have data, error, and loading. I'm just not going to use those right now. So now we have a function we can call generate submission, which executes this mutation. So on click of this button, I want to run the function generate submissions. Let's rename that to plural. Okay, now when I click this, nothing's going to happen because what should happen is it queues up a job, but we don't have any sort of automatic refreshing of this table or a subscription into new things coming in. That would be a great thing to add, but maybe in a different video. But I'm going to click this button. Let me go ahead and open up Network Inspector so I can see what happens. If I click it, we do get something here, status of 200. Looking good so far. We got a return true. Looking good so far. So that should have queued up 10 generate submissions. So I have 8 records right now. If I refresh this screen, I have 18. Let me click it again. Wait a second, refresh. I have 28. Yes. So this button is executing that mutation on the back end that is generating a job in our BoolMQ queue, which is stored in Redis, which is running in Docker, which is organized by Docker Compose, which then gets run in our backend worker, which then uses Faker to generate a submission, use Prisma to push that into Postgres, which is also in Docker, and then via GraphQL, we're able to run those and inspect those in our front end in a React app. So I think that's pretty cool. So this is a demo of how you could scaffold out, get a prototype working of a full stack web app. Again, Node, Postgres, Redis, queues, React, GraphQL. We added in type generation on GraphQL on the front end. Type generation on the back end, I would say, is just as powerful, if not more. You can actually get to where you're typing these resolvers. Given my troubles earlier getting the front end one to work, I don't think I'm going to attempt that here live, but you can use the same GraphQL code gen tool to generate types for the back end, and that is super powerful. But we do have Docker Compose here with Postgres, Redis backend. We've got all of that running. We've got our front end dashboard. We've got this running. It's all running locally. So in my next video, we're going to take this setup and push this to production and get all of these services running: Postgres, Redis, backend, and front end. That's 4 different services for our nice little form collector, form hub, data grid dashboard here, and get that working. So I hope you enjoyed this video. I hope this was useful to you. Leave me a comment down below if it was. Subscribe to my channel. And I will see you in the next video. So have a great day.